James Finn is considered a pioneer of educational technology who viewed technology as much more than machines. His service in the military, in the instructional aids and training department, spurred him to elevate audiovisual education to a professional field of study and to base it on research and theory. He was the first to create an instructional technology academic department. His early work concentrated on automation in education, and initially he considered automation to be an expansion of technology, but in the early 60s he changed his focus, emphasizing that technology was more than just machines, but that it included processes, management, human and non-human controls. Finn did remain a proponent of technology as a process. However, his work with audiovisual technology allowed researchers to recognize that technology was both a process and a vehicle. Contrary to Skinner, he approached programming from a communications perspective. Norman Crowder, a contemporary of Skinner, while working for the Armed Services, was involved in scientific research and development projects conducted by the Air Force Personnel Training and Research Center. Intrinsic programming was a byproduct of this research. He is considered the originator of the branching theory, also known as intrinsic programming. Products that resulted from this were Tutor Text, a series of instructional books, and he also was the inventor of the Auto Tutor, which was a standalone desktop teaching machine, and this came out in the early 1960s, long before general-purpose desktop computers were feasible. In an intrinsic or branching program, each frame is more textual than linear. After reading, the learner is prompted to respond to an adjunct question presented in a multiple-choice format. Intrinsic refers to the programming not relying on external sources. The intrinsic or branching capability is built directly into the programming. The key distinction between Skinner and Crowder is the function of the response in programmed learning. Skinner maintained that learning results from modifying the behavior as a result of consequences and uses a fixed programming technique. Crowder believed learning results from realignment of the learner's knowledge structure and uses his branching technique in programming. The response controls the program's relational branching, and thereby the response tests the level of the learner's ability to integrate information with what the learner already knows. While some claim that lower ability users benefit more from Skinner's linear approach and that higher ability users benefit from Crowder's approach, there's no real evidence to support that. Stanford University's Institute for Mathematical Studies in the Social Sciences and IBM partnered in 1963, and they developed the first comprehensive computer-assisted instruction curriculum for elementary schools. In 1967, the Computer Curriculum Corporation was established to market this computer-assisted instruction curriculum, and it was widely adopted in California and in Mississippi. The 70s is marked by continued acceptance of the cognitive approach to learning. Instructional strategies that mark this decade emphasize the contributions of many who fall into the Gagne, Brunner, Merrill, and Oswego camp. To recap, Gagne had described the nature of an instructional theory as an attempt to relate the external events of instruction to the outcomes of learning by showing how these events lead to appropriate support or enhancement of internal learning processes. In this period, Plato and Tissot were developed and used. New ID models were developed for solving different types of problems in the instructional environments. Needs assessment was accepted to be an important step in the ID models for planning and instructional procedures for learners. People such as Brunner, 1960, and Tyler, 1950, are among those whose work concentrated on matters of sequence and the content of learning. Bruner's concept of the spiral curriculum and Tyler's conception of the rationale for a course as its design beginning point are examples of curriculum thinkers' contributions to instructional thinking. The story of the Association for Educational Communications and Technology goes back to 1923 when they were first the National Education Association's Department of Visual Instruction, and then over the years their name changed. AECT has been highly instrumental during this time with instructional design, and in the past they were very much involved with representing professionals who had an interest in improving learning through the use of media and technology. In the 1970s, hypertext finally comes to fruition with Project Xanadu, the first hypertext project, which was founded by Ted Nelson in 1960, but he didn't actually publish his ideas until 1974 in his book Computer Lib, Dream Machines, and then later in 1981 in his book Literary Machines. The 1980s is about growth and redirection in instructional design. In terms of growth, interactivity and learner control were the hallmarks. CBT and CBI microcomputer instruction machines were in full swing. PCs found a market, and business and industry showed a strong interest in instructional design and performance technology. Unlike the business sector, budgetary constraints shows a slowdown in instructional design in the educational sector. There is, however, evidence of continued interest in the literature on how cognitive psychology could inform instructional design. However, according to Dick and Gustafson, there's little scientific evidence, though, of its effect on instructional practices. Also in the 80s, specifically in 1989, B.F. Skinner publishes an article entitled The Origin of Cognitive Thought. The 1990s was focused on more growth, adaptation, and constructivism. In the 1990s, constructivist views of learning and instruction gained popularity. Learners were required to solve complex realistic problems, work in groups, look at problems from a variety of perspectives, be active learners, and understand their role in the knowledge acquisition process. In other words, the learner, during interactivity with the environment, creates individual and social constructs which lead to the construction of meaning, and thereby learning occurs. There was continued growth in the 1990s in the business and industry sector, and as a result, the scope of instructional design field grew and broadened. Instructional designers became more aware of the analysis processes of performance problems, determined it wasn't always a training-related issue. They recognized the role of environmental or psychological issues, and the result was that computer-based performance tools and information were being built into these systems. More specifically, instructional designers were starting to build electronics performance support systems instead of training programs, and providing information and the tools electronically at the point of need. Trends in instructional design are rapid prototyping, in which prototype product is developed quickly, and early in the instructional design phase they go through essentially the system's lifespan cycle so that they can produce quality instructional materials in a shorter time frame. Integration of instructional design models is another trend, and both traditional and e-learning environments require the integration of technologies as part of instruction development, and this involves incorporating text, sound, imagery, and mobility into lessons in online modules. Distance education programs in a virtual environment have also created more opportunities for instructional designers, and as we are all aware, classroom instruction delivery and online instruction are very different, so replication isn't possible. A well-designed program for an online environment requires the integration of special features that communicate well virtually. Another trend that we see is organizational instructional design, which includes knowledge management within organizations and the use of technology to identify, document, organize, and disseminate knowledge and expertise. To conclude, the overlap of instructional design and instructional media is increasingly more evident and requires careful instructional planning to achieve desirable outcomes. While this has always been true, the emphasis has become even greater as we explore more media options. This concludes the historical part of this presentation. Thank you.